Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we'll be going to learn about single source shortest path. This is also one of the problem where we can apply greedy method, and this topic you'll find in third unit and topic number 3. Now let's get started to understand about what is single source shortest path. Now let's understand what is single source shortest path. Now assume that there was a road to travel from one city to the other city named as A city to B city. Now we'll use a graph to represent these kind of things. Now highway is represented, this is represented with edge, and these A comma B cities are represented with vertex. Now the picture of single source shortest path is, to any person wanted to travel from A city to B city, that is A vertex to B vertex, they will travel via this edge, correct? Now assume that there are two possible edges to reach this B. Okay, now which edge the people will select? Basically will select the shortest path, correct? So when I'm using a term which is shortest path, you can understand this is also a minimization problem. So where minimization and maximization result will come into the picture, there we'll apply greedy method. So this is also optimization problem and minimization problem. Now, so we'll be going to apply greedy method on this to find out the shortest path. And this shortest path not via all the vertex in between what are there. We will be going to take only the single source. So that is what the basic problem is, right? Now let's understand this with an example. I have given some example that let us assume that a motorist wishing to drive from city A to city B. So very common question this person will have, this motorist will have, is there a path from A to B? If there is more than one path from A to B, which is the shortest path? So we are going to handle these two problems. If you can see a path from A to B, then we will be looking at the cost. What is the path? The cost or the distance or the average time. These are given in an edge if it is existed. If it is not existed, obviously we'll not choose this path and we'll choose the other path. Question comes into our mind, if to reach B city, if you have many other ways via some intermediate cities, then which is the shortest path? So this is going to be solved using some example. Now single source shortest path is going to be applied on undirected graph and directed graph. Will be take two examples, undirected and directed. So here you can find out a directed graph. Even I can say that undirected graph, that something like this. Now 3, 5, some 8. Now I can make this undirected graph into directed graph. How I can make? Every undirected graph is equal to directed graph if and only if the distance of u comma v always is equal to v comma u. That means 1 comma 2 direction, the cost what is from 1 to 2, the same cost will be from 2 to 1. This is the way how I can make. 5 is 1 to 3, the same is from 3 to 1. 2 to 3 the cost is 8, from 3 to 2 the cost is 8. Now likewise I can make this is into directed graph. So point is, single source shortest path problem can use undirected graph, can use directed graph. Now let us understand how to solve this kind of problem. Now I'll take a small portion of this graph for the better understanding. The portion of the graph is what? Let us assume that I have a path from 1 to 2, and as far as the above graph is considered, I have path 1 to 2 and I have a path from 2 to 3. So 1 to 2, the path is what? 2. Now, I do not have a direct path from 1 to 3, correct? As I cannot see, or as I cannot have path from single source, the source is what? 1. I am considering this is my single source. Whichever paths are existed from this source, I am going to consider that path. But I have only 1 to 2 path. So, the cost to reach this 2 vertex is what? 2. Now, I am at 2. So, the cost in between 1 to 3 edge is what? Infinite. Correct? Now, 2 to 3 cost is what? Let us assume the 2 to 3 cost is some 4. So, to reach from 1 to 3, I will be traveling through this second node, correct? So, now 1 to 2 I am traveling, 2 to 3 also I am traveling. So, the total cost to reach this third vertex, 2 plus 4 equal to 6. Now, which is the minimum? It is actually infinite. When I travel from 1 to 3, it is of infinite. When I choose this intermediary path or the other's path, other vertex via the other vertex, then the path is what? 6. Which is minimum? 6 is the minimum. Now infinite will get updated with 6. Okay. Now this is the way how we have to find shortest path from single source. Let us discuss the algorithm, then we'll come back to this problem to find the solution. Now the algorithm is what? We will be going to calculate shortest path. The parameters are number of vertices and cost, distance and the n value. So now we will be starting from one vertex to the all vertex. So we are taking some array and distance of I is nothing but cost of v comma I. And distance of v is what? 0.0. Now what we are going to do is we'll be going to compare this condition, that is distance of w. Let us see that 1 2 3. So this is what your u and this is what your w. W cost is actually what? Infinite, because I am considering the first vertex. I do not have a path from 1 to 3, hence it is no path and hence it is infinite, because I cannot have a finite value. Now distance of w is what? Greater than the distance of u plus cost of uw. Now that will get updated. Now distance w is updated with what? Distance of u. Distance of u is what? 2. Distance of u is 2 plus cost of uw. Cost of uw is what? 4. 2 plus 4 is equal to 6 will get updated in distance. So this is what? Relaxation. Relaxation is what? I am relaxing the other vertex when I travel from the intermediary vertex or via other vertex. So this is what the procedure of single source shortest path. Now we'll see some example. We'll see previous example also. Now look at. So I'm at starting vertex which is 1. Assume that starting vertex is 1. When I am at 1, how many paths I have? 1 to 2 I can travel, 1 to 3 I can travel. Among these two edges, which is the shortest path? 1 to 2 is the shortest path. Now I am traveling from 1 to 2. So now at vertex 2 the cost is what? 2. At vertex 3 the cost is what? 4. And as I do not find any edge from 1 to 4, it is infinite. As I do not have edge from 1 to 5, it is infinite, and it is also infinite. Right? Now, so I am at second vertex. I wanted to travel to fourth. Now what we will be doing? We will be finding the shortest path. So what is the shortest path? It is actually infinite. So is there any other path to travel to 4? Yes. From 2 to 4 if I travel, it is 7. Okay. Now 2 plus 7 it becomes what? 9. Is there any other path? You can see this also, that if I travel from 2 to 3, then it will be what? It is 1. So it is 1. Now it is what? 2. 2 plus 1 it is 3. So here we have here 4. 4 and 3, which is shortest path? 3 is the shortest path. Now we'll update this value, which is 3. Now from this, the cost at 3 is 3. Now if you wanted to travel to this 5, from 1 to 5 it is infinite. If you take the help of this third vertex, now the cost will become cost of u plus w, it becomes 6, infinite in the place of 6. Now, is there any other shortest path? You can also find it that. So 1 to 6 you don't have any path. From 1 to 5 the path is 6. Now if you travel 5 to 6, the cost, it is infinite. Now the shortest is what? 11. Now from after 6 you don't have any path, correct? So from 6 there is no outgoing direction. So till we will finish till 6. So what is the shortest path from 1 to 6? That you can travel from 1 to 3 and from 3 to 5 and from 5 to 6. So this is what shortest path. Now we'll take the other example also. See, this is what your book example. I am following actually Horowitz's book, Algorithms, Horowitz and Sahani, Fundamental, the prescribed textbook from university. You can consider, you please refer that textbook. You'll find more exercises in that textbook. It is one of the exercise. Now, as far as this problem is considered, I am taking starting vertex is 1. So when I am taking starting vertex is 1. Now, from 1, what are the paths you can see? From 1 to 2, the cost is 50. 1 to 2, the cost is 50, we updated. 1 to 3, the cost is what? 45, we updated. 1 to 4, the cost is 10. 1 to 5, naturally you didn't have any path. So 1 to 5 there is no path, so it is infinite. 1 to 6 also it is infinite. Now which path you are selecting? Selected vertex. Among all this, which is having shortest path? 10 is having shortest path. Now I am selecting 4. Now, so we are at 4 vertex now. So 4 vertex cost is what? 10. Now from 4 you can see the cost of all things. From 4 to 5 it is what? From 4 to 5, from 4 to 2, because you have vertex from 4 to 2. 4 to 2 there is no edge, correct? 4 to 2 there is no edge. So as it is right, it is 50 as it is updated earlier. Now 4 to 3 there is no edge. So as there is no edge, it is infinite. If you compare with these figures, these are the less than from infinite. So consider this, right? Now it is 10 we already considered, and 4 to 5, what is the edge? If you travel to this, you don't have any path, but you can take the help of this 4 vertex. That means 10 is here, 15 is here. Basically it is infinite, but it is maximum. If you compare with 10 plus 15, it is 25. So I am writing it is 25. Now again it is infinite. Now where we are at 5th vertex. Now take 5th vertex. So this is already finished. Now the minimum is what? 25. Now consider the 25. Now, so we are at 5. From 5th vertex to 2nd vertex, do you have any path over here to travel from? We are traveling from 1, right? Single source. 1 to 5 we came. So at 5 the cost is 25. If I wanted to travel to 2, it is 25 plus 20, 45. But to travel from 1 to 2, it is already 50. Which is the lowest path, the shortest path? 50 or 45? 45. So update the value, which is 45. Now it is 45 as it is. 10, 25 as it is. 10 and 25 are finished. Among these all, 45 is the lowest path. I am selecting 2nd vertex. Now I am at 2nd vertex. When you are at 2nd vertex, now what are the paths you have? 3rd. So at 2nd it is what? 45, correct? At 2nd it is 45. Now to travel to 3rd. So when you wanted to travel to 3rd from 2nd vertex, 45 plus 10, 55 it becomes, correct? So already 3rd is having 45. If you travel 45 plus 10, it becomes 55, which is shortest path. 45 is the shortest path. So consider directly 45 again, 10, 25, infinite. Now, so this 10, 25, 45 are completed. Now I am considering the third vertex. From third vertex, where I should go, there is only the path which is to 5. Correct? There is no path to 6. 6 is unreachable because there is no edge which is to 6. So 6 obviously 10. So that is what, again we will be writing 45, 45, 10, 9, 25. So this is what the shortest path. As I cannot have any reachable edge, it is infinite. And as far as the complexity is considered, we are visiting all the vertex and all the edges. But some point of time, this all the vertex are n and this e also becomes n. So it is big O of n square. So this is about single source shortest path. Thank you all.